Let's just do it.
You good? I didn't know you were going to say something else.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 311, AirTag hack, GPS rollover, and a flat pack toaster. This week in Hackaday news, if you are listening to this on Friday, which I know you are, and we're recording this on Wednesday, in our future, in your past, is the announcement of the Hackaday Europe keynote speaker, who is going to be David Cuartielles, who is one of the 4 principal founders of Arduino and a researcher in embedded and cutting-edge interactive devices.
Ooh.
I'm intrigued and excited to hear his talk. The title is going to be, What If the Future of Electronics Was Compostable? And he's going to get into biodegradable and otherwise recyclable electronics. And he's been doing a lot of research over the last 5-10 years into different prototyping methods. You know, I mean, what do you expect from one of the dudes who started up the whole Arduino thing? And I think we've all seen how the kind of Arduino / educational electronics movement has gone from being something you'd teach in college to being something that people are just picking up on their own, thanks in no small part, I guess, to Arduino, but also to the gigantic community of hackers working on these projects and documenting them and making awesome instructions and how-tos and just showing their work. And so excited to see what he thinks the future is going to look like.
Yeah, it's a fascinating topic. You know, when I first heard it, it did kind of shock me a little bit because it's definitely not what I expected, right? It's not a topic I often think about, but, you know, now the more it's in my brain, I want to hear more about it. And, you know, there's a lot of interesting challenges there, but it would be certainly a worthy goal. You know, we talk a lot about stuff ending up in landfills and trying to prevent that. But the reality is a lot of stuff's going to get thrown away, you know, and if we could make it break down, I mean, that'd be huge compared to what we're dealing with now.
For sure.
I mean, if you think about it, just a substrate that easily breaks down or is even like liquid soluble or something would be huge. Imagine like salvaging the parts. If you could just put a whole board in something and all that would be left would be the traces and the components, that'd be pretty awesome.
Yeah, then you heat that up and those melt off. Oh, that's not bad. That's not bad.
If you could just make a less icky PCB substrate than FR4, like that would alone be pretty huge.
Yeah, I mean, the trick with fiberglass is it's forever, right? Like epoxy fiberglass is super durable. But that, on the other hand, means, of course, you can't have trouble getting rid of it. Yeah, well, anyway. Keynote speaker announced, and Hackaday Europe is next week, folks. So if you don't have your tickets, get them now, and we'll see you next Friday.
Well, in software news, we got word over the weekend that Microsoft will be shutting down Skype on May 5th. If you are one of the people who was surprised to hear that Skype was still a thing, like me, this might not come as a big shock, right? The world has kind of moved on from Skype, but it was, you know, for its time, a pretty huge deal. The idea you could just jump on a computer and call somebody for free. It's one of those things we take for granted now with all the Discord and all the stuff we have that is available. That there was a time where Skype was revolutionary, right? But it ultimately, for those who weren't following the history of it, came out in 2003 and was a victim of Microsoft's embrace and extinguish kind of thing in 2011. So they grabbed it and took pretty much all the good ideas out of it to integrate into Teams and their own projects. And, you know, it's just kind of been hanging on in name only, I guess, since then. So the fact that it's now finally going away is not, it probably doesn't come as a surprise to anybody who's followed this kind of thing. But still, you know, pour one out for one of the original ways of using your computer to harass people at a distance.
My mom still uses Skype. I think she's the last remaining Skype user. So I have a Skype install on my computer because I use it to talk with my mom sometimes.
Well, they were holding on for her.
She's going to be devastated.
They're like, we tried to wait her out, but we couldn't.
This is a journey into sound.
What's that sound?
What's that sound?
All right, well, let's head on to What's That Sound? This is a Guess the Sound week, a brand new sound that I haven't uploaded yet. Hold on a sec. Let me just be taking care of that. This is a really short sound this week. You might have to listen to it a couple times.
Oh. Wow, yeah. Let me give that another one.
It's got a front, it's got a middle, it's got an end part of the sound.
I mean, it's one of those things the mechanism I can imagine. It's like a ratcheting, pull back, and then release. But, ooh, I don't know. I want to at least make a guess, but I can't.
Give yourself a second. You gotta. Sometimes you have to
Yeah, let me listen.
let the what that sound sink in.
I'm not confident in this at all, but the only thing I keep thinking of is the little, little lances that you have to check like your blood sugar or whatever.
Ah, not bad. Not bad.
That's all. That's the only thing that keeps sticking in my head, and I can't get past that. So I guess that's my official guess.
Unfortunately, not right. But our listeners have a chance to one up Tom Nardi. That's not very nice. But you out there, if you think you know what it is, play it back and forth a couple times. Give it your best shot. Head on over to hackaday.com/podcast. Fill in the form, and we'll see who got it right next week. After last week's abysmal sound on my part that nobody got, I hope somebody gets this one. All right, well, let's start up the hacks. I wanted to start off this week with a hacky hack. This is a research paper from a quartet from George Mason University, Junming Chen, Xiaoyue Ma, Lanan Luo, and Chang Zheng. The work is on Apple's AirTags. This is called Hijacking AirTag Infrastructure to Track Arbitrary Devices. And their website kind of warns you a little bit about the impact of this, but doesn't give you the technical details. On the other hand, if you click through to their PDF, it's a really nice research paper, which is called Turning a Bluetooth Device into an Apple AirTag Without Root Privileges. And that actually is the main point here of this hack. I can't even remember when the Open Haystack hack was, but a group of researchers from here in Germany wrote some software to spoof an Apple AirTag called Open Haystack. And there they basically just reverse engineered the protocol, and you send the right BLE data out, and Apple doesn't know whether it's a legit device or not, and you can track it. So you can make your own AirTag out of, say, an ESP32 or any microcontroller that is able to control the Bluetooth radio. So when your device sends out a BLE ping, listeners around it, and that is kind of any iPhone in the vicinity, hears the message and then transmits the device's location encrypted with the public key that your device sends to them through Bluetooth Low Energy off to the internet. And then you can search for that public key and then decrypt it with your private key part of it. So you can find out where the device is, but nobody without the private key can tell where your device is. What's funny about this is that the public key is 28 bytes, and when you add that together with the location information, you actually get 37-byte data string, which is just too long to fit into a Bluetooth Low Energy announcement. BLE announcement packets are 31 bytes. So you've got too many bytes here, and the Apple engineers pulled off a weird hack. That is, they changed the device's Bluetooth address. They changed its MAC address equivalent, but for Bluetooth, to make up for the extra 6 bytes. So they take 6 bytes of the data and they spoof that into the device's address. A weird hack. What the upshot of that means is that if you can't change the device's Bluetooth address, that is, if you don't have root on the device and can't run some code that changes its Bluetooth address, you can't send arbitrary AirTag packets. And so, if you're making your own out of an ESP32, this is moot. You run all the code, everything's cool. But if you wanted to do something malicious, like install a piece of malware on somebody's phone that then made it behave like an AirTag, you couldn't do that without root permissions because the malicious app would have to be able to change the BLE ID. So the remainder of this BLE address should be a random number, and that's actually in the Apple AirTag spec. The researchers found out that a bunch of implementations used the old school BLE address, where the beginning of the BLE address is the manufacturer's ID. And this gave them a very small universe of manufacturer IDs instead of a huge random number space to search in. And so then they could take this and make essentially rainbow tables to figure out where all of the possible location messages would be for every Samsung device, for every Android device, for every et cetera, et cetera. So any of the devices that used their own manufacturer ID string as the first part of that MAC address packet is subject to this attack here. The researchers, of course, disclosed this to Apple, said, hey, your devices are accepting these invalid MAC addresses where it should be random, but it actually matches a known one. And that's leading to this compromise in the system. Apparently, Apple's already fixed it, so they've rolled out a fix to this. They no longer location tag and forward illegal MAC address combos where the MAC address isn't actually randomized anymore. So that solves the problem, except it doesn't solve it for all the old devices out there that haven't had their OS updated yet. It's a really neat hack, and the paper itself is a really neat deep dive into how Apple's AirTag ecosystem works, and I think that's really neat too. Plus, this adds the cryptography / rainbow tables / whatever quasi black hatty side of things over the top of it. It also means, of course, that, user space applications on cell phones and other devices where you don't have root can be spoofed this way, can be turned into AirTags this way, which they otherwise couldn't. So, opens up possibilities for good and for bad.
Well, that's really the heart of the matter, right? Possibilities for good and for bad. It's kind of how I would describe all the hacking we've seen with the whole service. It is kind of amazing.
Yeah.
All this, I can't really think of another commercial service that's been futzed with so much, over the years. Like, we've seen a lot of hacks that use this, and I guess it's just because it is so popular, right? If you got every iPhone in the world out there scanning for stuff, hackers are going to want to leverage that for their own nefarious or otherwise purposes. Some of them have been for good. Like you said, there's some people who just wanted to add their own devices to the network and didn't want to pay the Apple tax necessarily. And other people are looking for ways to track their ex-girlfriend. And it's really been kind of a wild west with this service. And, now Google has their own, which we haven't seen a whole lot of, I think, attention. But I mean, conceptually, it's the same deal. Somebody does say in the comments, actually, that you could similar method against theirs.
The real problem here is it's bad cryptography on the part of the sending device. The sending device should be sending all of its bytes randomized, and by sending the manufacturer's ID as the first part of the kind of MAC address, they're totally screwing that up, and they're leaving a lot of entropy on the table. And that's basically what these researchers are exploiting.
Man, the tile people have to be kind of salty, right? Imagine you come up with the idea of this, and then Apple comes along and is like, hey, I like that idea. I think I'm going to take that idea.
I think we'll just borrow that.
Yeah, it's like that meme, like, I made this. Like, Tile had this idea, and, good for them, and then Apple comes along and eats their lunch. And the secret sauce is having the device manufacturer build it into all their handsets, right? Like, that was the problem with Tile. Is like, everybody has to get the Tile app on their phone. And it's like, okay, well, how many 3% of smartphone owners are going to have the app, Whereas if you bake it into the OS, now millions and millions of devices that are actively scanning, and there you go.
But then you also have the privacy nightmare that comes along with having everybody's device be a snooper by default. I mean, this is that was a YOLO move by Apple. You did what? We rolled out an international location reporting service.
Actually, over the last summer, I found some guy's wallet, and it had a Tile in it. His email address was on it. So I emailed him, and I was like, I found your wallet. And he's like, oh, man. So we meet up, and I give it to him. And I was like, did the Tile thing not work? And he's like, nah, dude. Like, he's like, he goes, unless you're like in, New York City or, Philly or something where there's a huge density of other people who might have Tile. He's like, once you get to the beach or something, forget about it because nobody has the app. So it doesn't work. But at least it had a place for him to write his email address. So effectively it was the same as a business card. Well, my first one this week is a cheap fiber optic wand toy becomes tiny, weird display. You may have seen this one. This one's been making the rounds on YouTube. I think when I looked at it, it was over 1 million views in a very short amount of time because it's a really cool project. It takes those weird fiber optic wands that have been, I don't know, a thing forever, where it's just a little cheap flashlight with, maybe a couple feet of fiber optics, and a kid shakes it, I guess. That's fun. it's fun for the kids.
Yeah.
I don't know. It's probably just some way for some company to get rid of short lengths of fiber optics they didn't know what else to do with. But in this case, it's the fiber optic bundle has been taken out and all smushed into a flat surface that becomes the display. And each one of the strands has been meticulously separated and put into this loom kind of deal, which is then laid on an LED matrix, and by lighting up the LEDs, the fiber optic lights up, which ends up, becoming a pixel of sorts on this little round disc. It's just really cool. It looks like almost organic in a way. It looks like alien technology to me, like when it's going through things on the display. One of I think the coolest parts of the project, which I don't know that was actually mentioned in our write-up, as I'm watching the video and all the little strands are getting sorted out, I'm like, okay, they're getting sorted, but they'll tell you roughly where they are. But how do you actually get it to like the pixel accuracy you need to draw a number or a shape or something on there, without manually following each one back to the front? And the answer to that is, once the display was built, there was no obvious correspondence between the LEDs and what would show up on the display. So like a computer vision tool was used, and it ran through all the possible permutations of where the LEDs would light up and what the corresponding fiber optic lit up. And then it was able to kind of make a mapping. And then using that, you could say, if I light this LED, this particular fiber optic on the display lights up. And I think that was actually one of the coolest parts of this, because without that, you would have, a neat random light device, but it wouldn't be a useful display that it could actually show shapes and text and numbers the way it does now.
I had exactly the same question. Like, how does he map out the strung out strings over the LEDs to this little round display? And of course, you don't want to do that by hand. You absolutely have to do that using a computer. And so what you do is you really just light up each pixel, take a picture, and say, where does that pixel end up? And then you're like, okay, here's pixel 2. Where does that end up? Okay, here's pixel 3. Where does that end up? You just pixel map the whole thing out. I think the coolest version of that I've ever seen was with one of these addressable RGB LED strings done around a Christmas tree. And then just like, where does this dot show up on the Christmas tree? Where does this one show up? I'll leave the link in the show notes. You have to see bringing a Christmas lights show inside where he's actually pixel mapped his Christmas tree. It's pretty, it's hella gaudy, but it's pretty awesome. That's one of those deep revelations that you've got this problem that's like, either I could map this all out by hand and it's going to be an impossible problem, or I can point a webcam at it and see what happens. And that's like I just love the beauty of how simple the solution is once you throw a tiny bit of software at it. And it really is light up this light, which pixel on the webcam lights up, and then repeat this, right? And then that tells you where they all go. And then you've got your image map.
Yeah, this is definitely a task for automation.
You couldn't do it without the software, and the software is so not difficult in a way that it just makes it so superbly simple all of a sudden.
And even if you were, bored enough to say, like, I'll do this by hand, like, you really couldn't, because it's not like the end display side is in any kind of human parsable order, right? It's not like in a grid, because all these little random round fibers have just kind of smushed wherever they are. So you can't even really say, okay, it's row whatever, column whatever, because they're just all over. It reminds me of the tests actually where they see if you're colorblind, right? And it has all like those little random dots. Like, that's kind of what it looks like. There's no, grid or whatever to actually track back. So even with the software doing the heavy lifting, it's not, like I said, it has almost an organic kind of look to it. It's not the rigid row by column pixel sort of display that we're used to.
I love that. That's how I'm going to do all of my PCB layout from now on. I'm just going to draw random wires everywhere. I'll just assign the GPIOs later.
Another thing, when I was watching this, the core technology here actually reminded me of something we had covered a few years ago, which was that in the F-18 fighter, which was designed in the 70s or whatever, they wanted to have little displays that could, I guess, do like the radio frequencies and latitude, longitudes, whatever. But there was no such thing as tiny LED alphanumeric displays at that point, because you're talking about like the display was like a half-inch tall or something. So what they did was they used fiber optics, and they made what we would consider like, the 7-segment or 16-segment thing out of fiber optic, and then each of those fiber optics was then run to like a halogen light bulb behind the dashboard. So you had this tiny little display from the pilot's perspective, but behind it was this, big mass of fibers and bulbs that were as small as they could make them for the time. And it's kind of interesting to see that, revisited in this more or less orderly way, So instead of those fibers terminating into like an obvious digit shape or whatever, it's just wherever they lay.
My next hack comes from Tom Verbuer. Interposer helps GPS receiver overcome its age. And Tom's a little bit of a time nut, and this is the story of fixing up an old Symmetricom sync server S200. And what this thing is a GPS disciplined high frequency reference clock, basically. So it puts out a 10 megahertz clock. When it gets a GPS lock, it's dead on 10 megahertz. It's like 10.0000 something. But this one wasn't getting a GPS lock. And as Tom writes, it had a very irritating 9,999,993 hertz signal.
I hate when that happens.
Does not work if you're chasing accuracy in your 10 megahertz clock. So he had to get the GPS discipline part up and running again. And so what this does is it uses the every pulse per second that comes from a GPS, which, if it's properly designed to do this, comes directly from a satellite. And so it is as good a time reference as you can possibly get. And then you make sure that you get 10 million counts in between these, and you are done. The problem is that this is an old unit, and it suffers from the, quote, weak number rollover problem. And that's WEEK, because GPS is such an old protocol that they encoded the time in it with a number of weeks. So this is a little bit like the Unix epoch thing, except number of weeks since a given date. But there are only 1,024 of them. And so every just about
20 years,
they roll over. And so manufacturers compensate for this by like putting an offset in there. So they say the device was made on week number 513. So any number that's less than 513, we're going to assume it's rolled over and moved on to the next one. But that still only gets you a
20 years
approximately lifespan for the device, and this one is older than that. So it didn't know what time it was and couldn't find the GPS satellites and couldn't get a lock. Now what do? The answer, if you're Tom, is you sneak a little board in there that gives the GPS unit the correct time setting code. It actually has like a boot up time code that says, starting with what date should I start looking for the satellite's position? And so instead of having it be 10 years in the past, he says today is sometime in 2024, and then passes all the rest of the data transparently between the GPS unit and the Symmetricom. So he made this really sweet little board. It's got an RP2040 on it. All it does when it starts up is give it this command to tell the GPS the current date, and everything else is entirely transparent, and it works from there. It's a really cute solution to this problem.
I think probably like a lot of people look at this one. My first kind of response was like, seems remarkably short-sighted for GPS. Like it seems, it's hard to believe that they never saw this problem coming. I mean, I guess maybe the idea was like client devices wouldn't be that old, but I mean, especially if you think about, GPS was originally designed for military use. the intention when GPS was introduced was certainly not for it to become the thing that we all rely on for our daily life. It sort of just turned that way. It's a little bit like, I suppose, the ARPANET ultimately becoming the internet. It started as a much smaller, like, scientific thing, and then, the military used it, and then it just trickles down to us. Like, I guess the comparison would be like the IP4 situation, right? Like, there was limitations built in from the start that seemed reasonable when it was a relatively small group of people using it, and then as time goes on, you're like, what? That wasn't such a great idea. Maybe we should have added a couple digits to that number, and here you are.
When every bit counts, you have to transmit them from satellites to every receiver everywhere. I don't fault them for it. On the other hand, it's one of those, and it's a known problem, and most GPS manufacturers have a command, like an initialization command, like Tom pointed out here, where you can say, hey, I think the date is this. Interpret the rollover as if it starts from this date. And that solves the problem, right? So in some sense, I think the design flaw here isn't really GPS, but the time server clock reference thing that he's got that isn't smart enough to tell the GPS unit what epoch it thinks it's in. If you could just have all the devices take care of that, you'd be fine. If you haven't heard about the week number rollover problem before, you should really go read Dan Maloney's article, Countdown to the GPS Timepocalypse, because there was a rollover in April of 2019, and it actually caused a bunch of trouble with the ADS-B system that's used in commercial airlines to have the planes tell each other where they think they are. And a bunch of them had problems with it. And so we have a follow-up article right after we wrote up GPS and ADS-B problems cause canceled flights. It's like half of the US got grounded for a couple days because of this. So it's no joke. It hit our car, actually. Our navigation system in our car didn't work until we got a firmware update on the GPS system. We got bitten by it ourselves. So it's really neat. And if you think that's the last of it, of course, there's the 32-bit Unix epoch ends in 2038, which is still far away, but it's sneaking up on us. And if you manage to live through the Y2K problem, where again, it was just, it's just saving bytes, right? It's like, it's 1987. You don't have to write the 19. Next year's going to be 1988. You don't have to write the 19 until it's 2001. So anyway, we're there all over again. We'll see what happens. I can't wait for 2038.
Man, that's a shirt if I ever heard one. I can't wait for 2038.
Tell you what. Yeah.
Well, this next one is from Wesley Ellis, and it is a cheap hackable smart ring gets a command line client. This would be Hackaday worthy news in general, I think, if you took some wearable and figured out a way to pull the info off of it with a open source Python script that, circumvented the probably spyware mobile app that you are intended to use, keeping the data offline and keeping it in your own systems. But what I really liked in addition to that is that this is kind of a domino effect of something we covered a year earlier, which was when Aaron Christoffel, go back a couple steps. If you're not familiar with Aaron, he has, I guess, a hobby, you would call it, where he just buys cheap stuff on AliExpress and hacks it and kind of just moves on to the next one. He has a very just like, he plants the seeds, right, for other people's work, which is something I really appreciate. He'll find some cool thing like a cheap ring, and he'll buy it and he'll hack it, reverse engineer it, put all the information out there, and then like in 2 weeks later he has another weirdo thing that he's doing it with. When that first came out, Wesley was kind of interested. He saw the Hackaday coverage of that and saw the work that Aaron did it and was like, well, that sounds fun, and picked up one of these rings and started working on the Python client. And I just think it's really cool to see that sort of, one hacker says, hey, here's a cool thing that's cheap, let's play with it, and does sort of the groundwork and publishes that, right? And then someone else picks that up and kind of puts their own spin on it, and pretty soon this little smart ring that otherwise probably nobody would even know about becomes like the next thing that everybody has to have at, the HackerCon. And I think it's really cool to see that happen. It's less cool when like the prices on all the stuff skyrockets because suddenly there's a demand for this, obscure little gadget that otherwise would have been languishing on a shelf in a stock room somewhere. But we take the good with the bad here. I almost had like the wrong impression at first, as I know that Aaron, he laid some of the groundwork for doing a replacement firmware in that he showed, like, he got the SDK working and showed that there was no encryption or anything that prevented you from just flashing a new firmware. It was just up to somebody who was so inclined to write it. And I initially thought that this new project tied into that, but looking into it deeper, this actually does work with the original stock firmware on the ring. So, if you are interested and you were worried, like, oh, do I have to, what a thing to say. If you're worried about flashing your ring with a different firmware, don't worry. You can actually just take it right out of the box and use this Python client to pull the info out of it, which I guess I should clarify is like heart rate. I think it says pulse oximetry, steps, potentially gestures too, but I think there's still some commands unexplored. Sleep tracking. There's an impressive amount of stuff in this like $20 ring. So yeah, if you're interested in that kind of thing and you want an easy way to get the info out of it that you could then manipulate, this is definitely a project to take a look at.
But in a way, that's even cooler, right? Like, assume you bought this thing because you were interested in any of its functionality. Now you have that under your own control. You don't have to use their stupid app. I mean, it's absolutely lovely. This is why we do reverse engineering.
And we know realistically the reason these things are cheap is because they want you to use the app and they want you to sell your info or whatever they're doing with it. So this is kind of an end run around that, which I really appreciate. That we get the benefit of the cheap hardware, but without having to go through the subsidy of having our info sold to whoever's interested in my blood oxygen level while I'm recording a podcast. But I should say, as we've seen with some of Aaron's other work, that does occasionally draw the ire of the company who's making this thing. He did the custom firmware for a really cool Bluetooth thermometer that we have covered pretty extensively. And the same thing, like you were supposed to use the Xiaomi, My House app or whatever. His firmware let you just pull the info right out of the BLE advertising packets and just completely avoiding any kind of proprietary stuff. And you could just pull the data literally out of the air. You didn't even have to connect to it. The thing got really popular and people were buying them, and there's all these custom firmwares and all this. And then eventually Xiaomi was like, wait a minute. Wait a minute. We don't like this. Like, you're supposed to be using our apps. And now the security comes in, and now it's, now they're fighting with the newer versions of the hardware, prevent the custom firmware. So it is kind of an arms race sometimes when this kind of disruptive thing gets added to the mix.
If they didn't have sketchy ulterior motives, they wouldn't mind it. And this pretty much proves that, like, I mean, nothing proves anything, but this is kind of a smoking gun that points to Xiaomi having weird data collection fetishes that I don't want to get into. If taking the thing offline makes them worry that it's not reporting back to them, yeah, that's a bad sign. Well, bringing up the rear for me is a constructive hack. This is inexpensive powder coating. A great video by Pete about how he made a fluid bed powder coat machine for himself. And he's making, I think it's like a bunch of little kids' bumper cars or something. And in previous episodes, he has cast aluminum steering wheels. And now he wants to powder coat them so that they look really nice. And if you're not familiar with powder coating, you basically stick a paint-like powder, what is it? Is it some kind of enamel or something? To the object in question, and then you bake it, and it melts and smooths out all over it, and it leaves this absolutely wonderful surface. And Pete looks around, and he finds that there are super small-scale fluid bed powder coating machines that people use for, like, he mentions fishing lures. And then there are huge ones that they use for, like, powder coating fences, an entire 12-foot by 4-foot fence sections. And he can't find anything in between. And so that is what this video is about, is kind of taking a tech that works on an industrial scale and then works on a super small scale and kind of filling in the gap in between, making something medium scale powder coat machine that otherwise doesn't exist. And what's fun about this is instead of spraying the powder on the thing, he's dipping it into a bed of basically just the powder, only it's a fluidized bed, which means there's enough air running through it that all the little powder particles are kind of jumping around in there so that you dip it in, it gets nicely evenly coated. But there's none of this mess that you get with spray powdering. So you don't have all that powder in your room. It's the clean and nice way to do a small run like this. What's fun about the video is that he spends a lot of time building the fluidized bed thing. And he has, some ideas in the beginning, like we'll just put a bunch of pinholes and regularly spaced and see what happens. And then it becomes pretty clear that the air isn't going where he wants it to or expects it to. So he breaks it up into a bunch of different zones, and he uses, I think, 6 different air hoses, all with little valves on them, so you can regulate the flow on each one of those so that the flow's the same across the zones. And then he goes to concentric rings, and he puts a filter over the top so it doesn't fall back down. And I mean, it's a really nicely documented hacker project because he starts off with kind of nothing. And then he makes prototype 0, which is just a total failure, but it shows him where the real problems are. And then he makes a couple prototypes that work and work and work. And by the 4th or 5th one, he's got an absolutely beautiful setup. It's the usual hacker iterative design thing, but he gets it right. And that's super rewarding in the end. Do I need a powder coating machine? Probably not, but it's fun to watch him do it. Oh yeah, the other trick, of course, is that the powder sticks best to the part if the part is put in while it's warm/hot, so that the enamely, plasticky powder stuff kind of melts a little bit and sticks to it. And then you bake it out afterwards. So he dips the part in hot, and then he has a toaster oven that he's modified with a rack on the inside that he can hang these parts in. And so he uses that for the 24-hour bake out period that they need later to get a nice smooth finish on them. Everything is totally hobbyist accessible. He's done the hard work of making these prototypes into something that works. Now, if you want to do it, you can just buy a manifold, 3D print this thing out, and scavenge a toaster oven from somewhere, and you're off to the races.
I think it is kind of an important distinction to make, and this was kind of happening in the comments a little bit. Like the reason he's doing it this way is because he has 16 identical round objects that are unusually well suited to being placed in this vat because they're all the same size, right? He's doing production. If you are just a hobbyist who wants to powder coat, this shouldn't dissuade you and think oh, I have to build a special thing and get, like you said, the manifold and the pump. You can just get a powder coating kit for, $100 or whatever to just spray arbitrary stuff and then bake it, But the cool thing here is really that it was optimized for his particular production, and that there's no wasted powder. Because that's the problem with the traditional gun, right? Is, it uses high voltage to electrify the part, which makes the powder stick to it, but there's a lot of overspray and, it makes a mess. But if you're doing one thing, it is what it is, because you're not going to make this whole rig for one object. This is a cool example of, taking the concept for small scale production. To be fair, he could have just sprayed him with a powder coating gun and dealt with the overspray, but this is a lot cooler than just picking up a kit from Harbor Freight and calling it a day.
Yeah, but now he can powder coat anything that's kind of, whatever, a foot that'll fit in this thing, he can powder coat it. You're totally right. It only makes sense if you're going to do a lot of powder coating. But now he's got it. If I were him, I'd be powder coating everything.
I mean, I guess it's not the worst shape and size of, a container. Like you said, anything that's within the diameter of that wheel will work. So it's not like it's some weird shape, for an intake manifold that only works on one thing. If you're going to do it this way, yeah, this is the way to do it, right?
You could put front panels in there. You could put...
Oh, yeah.
I don't know what people want to powder coat. I do love that the canonical powder coating method is to charge the heck up out of the particles and then put the opposite charge on the thing you want them to stick to and do it that way. I do love that. It's like high voltage spray painting. I think that's lovely.
Yes, that's remarkably accurate.
But I think that alone is awesome, but it doesn't make it any more convenient.
For my last one, this is flat pack toaster heats up the right to repair. we've spent a lot of digital ink anyway, talking about repairability and fixing things rather than tossing them. And obviously is a big topic for hackers and makers. And we all want to be able to repair our stuff. And if not repair it, at least be able to use the parts for something else. And just in general, stop this idea of everything being disposable, right? But that is often, maybe always, easier said than done. In this case, Casey Ho wanted to design a toaster that is easily repairable. And looking at consumer toasters, she quickly found that they are a nightmare to try to take apart. And, maybe for good reason, in the comments, it's kind of pointed out that, no user serviceable parts inside it definitely applies for like the average toaster user, right? So, maybe it's not surprised that your basic toaster is not so easily disassembled, but she found like they were just very hard to open without breaking them and just not a repairable thing. So she came up with a design that is, let's call it industrial looking. Sheet metal panels and exposed screws and easy to take apart. And, you pay a price for that in terms of aesthetics, I guess. And it kind of reminds me, which is really why I picked this one anyway, because in the comments, it started kind of a whole debate about, what are you willing to give up in terms of just design aesthetics and sleek, sexy consumer gadgets, if it means you can still open them up and work on them. And this is something that we've seen with, smartphones come to mind, right? Like that was the argument. Oh, we can't have the battery be replaceable because then, you have to add a battery door and that makes the phone thicker. And, we have to use the glue to hold the phone together because otherwise it's not waterproof. And some of those arguments are more valid than others. But it is, I think, generally true that if you're going to make something that's easy to take apart and uses normal screws and doesn't have any weird hidden fasteners, it will probably be less integrated and smooth than the alternative, right? And it just it's kind of an interesting discussion piece. Like, would you be willing to have this armor plate looking toaster in your kitchen if it meant you can easily fix it and repair it? Versus a injection molded case for the regular toaster that, can't be opened without cracking it and is basically a sealed box.
Are you asking me? Good Lord, this looks so much cleaner than like 90% of my projects. Everybody's bitching about how this like exquisite square, beautifully water jet cut stainless steel folded project looks compared to my janky stuff.
As far as like a Hackaday project goes, yeah, this does look amazing. But,
it uses
it's not hard to
screws
imagine.
instead of tape. It's like, this is high tech.
But it's not hard to imagine how, like, the average consumer, if they saw this one next to, whatever swoopy, sleek LED lit one, I think it's pretty clear that this isn't winning any beauty pageants, put it that way.
So what I love about this one is that it is not just recyclable and repairable, but it's actually meant to be constructed by the user. It actually comes flat packed. And so you actually have to put it together when you get it. It's not just that you can repair it, it's that you essentially have to repair it before it even works in the first place. And that is something that I think is a tremendous virtue. If you compare things that some of us who built 3D printers back when that was a weird and difficult thing to do, know about how those machines work with someone who just buys a 3D printer that works straight off the shelf. To them, it's a black box. To me, I can fix anything that goes wrong with it because I built the damn thing from a box of parts in the beginning. And this is the toaster equivalent of that. This is, you don't know how a toaster works. Oh, yes, you do. I put the whole thing together myself. And I think that's tremendously empowering, actually. And I think this is part of the design experiment that Casey's playing with here. It's not just that it's repairable, but that the fact that you have to build it, the fact that you have to kind of repair it in the first place, even to get it up on its feet, changes the way you feel about the device. You now understand it. You now know how it works. Whereas, average person X, they probably have some idea. They've probably looked in there and see the glowy coils, but that's as far as it goes. Whereas this is also kind of, an instructional course in toastering. How can you how can you hate that? I don't know. It's funny because responding to these comments actually led one of our other writers, Navar Bartz, to write up an article on the quote IKEA effect. Some assembly required makes us love things more, which is a documented psychological effect that when you have to put something together yourself, you appreciate it more, right? And it's like, this is the Lego model I built. You like that thing partly because you put the effort into it, right? And I know I feel that way. I've made some of the furniture in our house and it isn't as good looking as the professional furniture, and yet I like it more. It's true. And so I think there's a lot of that going on here too. And I think if anything, with how dissociated a lot of people are from the technology that surrounds them, something like this is tremendously useful as as an educational tool. The crazy rebel Marxist in me thinks that this is people taking control of the means of toast production.
Seizing the means of toast production. Yeah, absolutely.
You're not subject to Big Sunbeam. You've got your own toaster.
And then, of course, some in the comments were saying, how many toasters are you people going through that you need a repairable toaster? It is probably the singular most reliable thing in the kitchen, but you got to start somewhere, right? Like the build it yourself microwave obviously would have its own unique challenges compared to this. Now, are you doing all these quick hacks, or some of them reference other ones?
I'm doing all of them.
5 of them. That's a record, I think.
You can't stop me. At some point, we regularized on doing 3 quick hacks. Today, here comes 5. Sorry, Tom. My first one, speaking computer from the 1970s, Inazuma Denki has a little breakout board that he made for the AY38910, which is the same as the Yamaha YM2149, which is the sound chip that's in a whole bunch of early retro computers. He makes it talk in the strangest way possible. He records the waveform by storing it on his oscilloscope, dumping the CSV file, and then converting that into a PCM that he then fires back into this poor little unsuspecting sound chip. Next up, Orange Merker, build a parametric speaker of your own. This uses a huge array of tightly packed 40 kilohertz transducers, that is ultrasound transducers, to beamform and make a spotlight of sound. You can't hear it when it's in transit, but when it bounces off of an object, it demodulates. So that means when it bounces off your head, you hear it as if it's coming from inside your head. Or if you point it at a wall, everybody thinks there's a speaker on the wall. It's a sweet effect. Mikey Sklar, CNC router and fiber laser bring the best of both worlds to PCB prototyping. I thought this was one machine. It ends up being 2 machines. The secret is some really nice registration and jigs here, but he's got it doing everything from cutting out the PCB to, quote, etching it with the fiber laser, and then making a nice brass stencil with a sweet 3D printed jig to do the paste work. Oh, last week we talked about what should the successor to Doom be for games that we port. This was Lewin's idea, not mine. I'm stoked to see Doom ported to a caption call phone. So it comes to Doom again. Parker Reed, awesome work here. Building an interferometer with Lego. The Lego interferometer is the funniest pun on the LIGO interferometer I've ever heard. In contrast to LIGO, it's the smallest interferometer you've ever seen. Kyra Cole, thanks for the laugh.
Man, I did not get that until
the Lego interferometer.
Wow, that's cool.
I don't know if that's on purpose. If this isn't on purpose, oh well.
I mean, if I would be taking credit even if it wasn't. I'm like, yeah, that was definitely.
I totally meant that. I totally.
Of course, I did.
Yeah.
Well, my first quick hack is the Bus Pirate 5 short-can glitch, and this is about a new capability added to the Bus Pirate 5 firmware by Matt Brugman that allows you to do pretty impressive, for the price anyway, voltage glitching attacks on a piece of hardware. For those who might not know, there's a area of research for freaking out devices by either cutting their power or fluctuating the voltage they get at an opportune moment to confuse them. And with the new addition to the Bus Pirate firmware, plus a FET or something to actually control the power, You can program, turn the power off and on, however you want it to fiddle with the device's power and then hopefully trigger something unexpected. So this usually requires fairly expensive hardware. So the ability to do it on the Bus Pirate 5 is definitely another cool feature in an already very long list of cool things that the hardware can do. Next up, is this the oldest HD video online? And Jenny List wrote this one up. A video on YouTube from really interesting, but real with two E's. And this is about a HD video from 1985. Which may sound strange, but while we might think of HD as a modern technology, various versions were in work well beyond the common adoption of Blu-ray and that kind of stuff. And this was an experiment from Toshiba where they were using an analog method of recording high definition video that was actually 1035 interlaced compared to our common 1080 progressive. And it's interesting to see. It looks pretty good, especially for a video from 1985. It has kind of a weird ethereal kind of glow to it, which I'm not sure where that comes from, but compared to anything else that was recorded on a digital recorder in that time period, it's pretty impressive. It is apparently one of the only known recordings that exists from this technology because, surprise, surprise, this 80s HD tech didn't end up going anywhere in the grand scheme of things. So it's just cool to see almost, what could have been like an alternate reality version had things gone differently and Toshiba's technology had become mass market. This could have been the home movies people were making in the early 90s. And my last one is Wake, Boot, Repeat, Remote OS Selection with Grub and ESP. This is a really cool hack. This is like a perfect quick hack because it is sort of just a few lines of code and an explanation of how it works. But the very short version is apparently Grub is able to load a config file over HTTP. Who knew, right? So if you host a config file on an ESP, your computer, when it boots, can read that and then do whatever the config file says. So it doesn't take much more work to then be able to modify that config file. So you remotely can say, on next reboot, go into Linux or go into Windows or whatever it is you want to do. I've never found myself in a need to remotely change the operating system my computer was running, but if you ever found yourself in such a situation, this is definitely a pretty straightforward way to do it. And I think, like I said, the biggest takeaway for me was that Grub actually has built-in support for loading a config file over the network, which is pretty cool in itself.
Quick plug again, Daniel Dockno is giving a talk at Hackaday Europe.
Oh, I didn't even realize.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to pick Arya Voranova's review of FOSDEM 2025, a hardware hacker's haven. Now, if you don't know FOSDEM, it is a European open source software conference held every year in Brussels, early February, and Arya was there and took a bunch of pictures, hung out with a bunch of people, wrote it all up for us. It's lovely to see this kind of firsthand review of something, frankly, I've always wanted to get to and have never managed to pull off. Maybe next year. What's fun is that Arya goes with a view toward looking at the hardware side of what is ostensibly an open source software conference, but I probably don't need to tell you that all of open source hardware is made basically with open source software. And firmware lies in the middle of this somewhere, and it's all one big love fest on all different sides. She brings up a bunch of the large software projects, like, for instance, Postmarket OS, which aims at putting Linux on old tablet and smartphone devices. This is one of those perfect storm of kind of hardware people working with software people to make something like that work. Or large open source software projects that further hardware creation, like FreeCAD or KiCad and in fact, FreeCAD and KiCad got together and had a co-booth because, if you need to design the circuit and then you need to design the physical box around the circuit, it's nice to be able to do that together. So it's good to see them working together. MicroPython, the Arduino, TinyGo, all the people working on open source software platforms for embedded projects were there. Everybody hacking on old laptops, that's kind of a software project on the same side as it is a hardware project. So it's really neat to see this kind of fertile collaboration, I guess. And that's really, I like to see the hardware and software worlds blend together. Like, I'm a hardware guy, but I do know that hardware isn't anything without software. And like, we've just in this very show, what did we do? We talked about that fiber optic hack, which is basically cutting up a bunch of wires, hooking them up to LEDs, but then it's a clever software hack on the other side of it that makes it work. Yeah, I'm not going to throw any shade here. And it's lovely to see the software people embracing the kind of low-level hardware-y side of things too. And Arya's point of this basically is that if you think that open source software is just about operating system development or just about the kind of, I don't know, computer-y, science-y developing algorithms and routines and writing programming languages and all of this kind of very abstract stuff, I think you've missed what's happened over the last decade where the software people have gotten a lot nearer to hardware. And at the same time, the open source hardware movement has taken a lot of the ideas from the open source software world and brought them into our world. And so I think it's a lovely collaboration between the two. And Arya's conclusion is that although it's a software conference, there's plenty of hardware to be seen. And it's a great place for your average Hackaday reader.
I've never been to FOSDEM. I'm on the wrong side of the planet for it. I have a much better excuse than you do. I don't know why you haven't gotten there. But I've been aware of it for a long time. I actually have kind of the unique honor that somebody gave a talk on a tool that I wrote at I forget what year it was. So from then on, I was watching the stream and I was like, wow, this seems like a really cool. This seems like a really cool group of folks and a cool event. But I had no idea, actually, that there was anything... Like Arya says, I always just assumed it was software stuff. I mean, it's kind of in the name, right? It's like... So to see that there is, like, a growing hardware presence is really cool. And obviously, like, the lines are blurring. We talk about that all the time. Like, you could argue there's few purely hardware projects that we even cover anymore, right? I think, everything has some kind of software element to it anymore. With the rise of the microcontroller replacing, the 555, everything is now a mix of hardware and software. So this was kind of only the natural progression of things. I'm jealous. Like, I wanted to go to FOSDEM before, and now I want to go even more to see all these cool tables with the hardware out there and just people hacking on stuff and having a good time. I guess my impression was more, not only is it like a purely software thing, but I sort of thought of it as more, I don't know what's the right word here, a little more uptight, or more formal, I should say. Uptight seems, there's negative, like a little more formal of an event from what I expected. But this is definitely looks like a cool HackerCon to me, and definitely the kind of place where I would want to hang out.
I think the other part of the convergence is that hardware is cooler. Like,
there you go. Shots fired.
You want to see my bubble sort algorithm? No, nobody wants to see your damn bubble sort. Show us a picosat, show us a satellite that you put into space that runs your open source software. We're going to be stoked about that, right? Show me the robot arm that your algorithm controls. The algorithm? It's a bunch of numbers. Nobody likes abstract things. But like, you start driving the hardware with the abstract things and you got something, and hearkening back to the kind of Arduino revolution, right? Like, that was their point. The physical computing thing. Like you said, the early beginnings of there's a microcontroller in everything change that we've seen. It feeds both sides, and it's a lovely time to be a hacker.
You're right, because something that we struggle with even on Hackaday. You know, somebody sends in a thing and says, "Hey, I built a robot." Boom, great, no problem. If somebody sends in their tip and says, "Hey, I wrote a software tool," and it's like several times where someone sends in a cool program and we want to talk about it, but you kind of need pictures. Steve had explained, people are visual creatures. They want to see things. They want to have something they can hold in their hand, and yeah, that's a little tricky when it's just code running on a machine.
The hello world of programming is getting it to print hello world. The hello world of kind of this hardware-y world is blinking an LED, which is cooler, We're so surrounded by computers of every size, shape, and type that having a computer write whatever you say isn't as cool as it was back in the early 80s. When I was working on a Tandy color computer, it was awesome to be able to say print and, whatever bad word here, 20 go to 10, right? And the computer would spit out bad words ad infinitum. And I was 11 and I thought that was the best thing ever. It's not anymore. Nowadays, it's like, oh, look at this crazy, I don't know, Cylon LED array I built or something. I think that has brought screwing around with hardware and software to a new audience in a way that is somehow more appealing than it used to be. Or at least more appealing now than what used to be appealing to me as a kid was appealing, if you know what I mean.
So my pick for can't miss article is Tech in Plain Sight Shopping Cart Locks by Al Williams. And I gotta be honest, I picked this because the local Home Depot just got locking shopping carts, and I hate them. And everybody else seems to hate him, and the staff seems to hate him. And I immediately was like, who came up with this technology, and why did they do it to us, and what can we do to stop it? And lo and behold, Al Williams wrote up an article that goes over it, starting with like the earliest attempts. There's a patent going back to 1968. They used magnets and was essentially a wheel lock that, if you passed over a strong enough magnet, it would engage, but anyone with a strong enough magnet in their pocket could disengage said lock. So that didn't work for very long. It goes into the modern versions now, which I think by looking at them, it's got to be what the store is using, where you'll have like one wheel. One of these things is not like the other, right? There'll be 3 normal wheels, and like one will be this black chunky wheel. And inside there's like a motor and a gearbox that basically, there's a ring with teeth on it, and the gear has matching teeth on the inside. And the ring expands and catches the teeth, and then it doesn't rotate anymore, if that makes sense. How they are engaged can vary. Like sometimes they use wires in the ground, sometimes it's RF, but the mechanics of it are still kind of the same, where you have this interfacing of 2 wheels internally. It's funny, Al mentions that one of the downsides of this is if you put it on the front wheel, right? And the front wheel locks, well then, you could just do like a wheelie and still keep going. But at least at the Home Depot, they thought this through, because they actually put these little stirrup things on the back wheels that prevent you from lifting the front of the cart up. So you can't even do that when they lock. I'd love to know how they're interacting, because the biggest problem they have, in my experience, is that they lock like randomly, or they lock when they're not supposed to. So like you'll just be pushing it, it'll just stop, and it stops dead, and there's no moving it. Which unfortunately is not addressed in this article. Why did they work so poorly? We don't know. And then it goes on to talk about the fact that at DEF CON 29, there was actually a presentation given about denial of service of shopping carts that went into how the technology works and what the weaknesses are, and up to the point that some of the manufacturers' locks are actually susceptible to, if you play a tone on your phone, that will cause them to lock or unlock. And I may or may not be experimenting with that the next time I go to the local big box home improvement store. I swear I don't want to steal anything. I just want the thing to roll in the store. I know it's a lot to ask for a cart to roll, but
You what?
It's silly me wanting the thing to continue to roll as I push it. But yeah, just at least for me personally, a very timely Tech in Plain Sight. And one of those things where when it works, you don't think about it. We can't take it for granted. And then when it doesn't work, it is enough to ruin your day. So it was, at least for me, cool to see a little bit inside of it. And in hindsight, I guess the fact that someone is even given a DEF CON talk on it is, like, why not, right? Like, we're at the point where even shopping carts can be exploited. So it shouldn't be a surprise that somebody had a whole presentation at DEF CON about it.
Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. To follow our links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us a line, tips@hackaday.com. And until next week,
Keep on hacking.
boy, I'm really messing this up. I'm not happy with any of this.
The beauty of editing.
Exactly. Yeah, that's even worse.
How did Elliot know?
Super and blah, blah. It's a
Of course.
yeah,
man.
Yep.
Go
Go back, fix, undo, replace, cut, paste, fix.
How did I get into this? Rewind and pretend I said cut. Many people have strong opinions on toast.
Bread chauvinists.
Let's say, I think it's a good note to end it on.